let's get started.
I'm a really good guy.
So today, welcome. We'll go over your last quiz, objects and lists, and then the lecture today will be more about UML. We'll finish up talking about lists and saying comparable, which will be needed for your lab today. And then we'll go in and start talking about UML, which is what you're going to need, or UML with class diagrams, which is what you're going to need for when you do the design phase of your project. And oh yes, one last note. I will not be here on February 23rd. That's a week from today.
Why?
You want to know why?
Vacation?
Vacation? Oh, what a nice vacation. No, I have to adoption trainings on that day, so I'm going through that process, and that's the only day they'll do it.
It's exciting.
So yes, it's exciting. Only sad thing is they won't let me bring my kids. I was like, this doesn't make any sense. So
You don't train with kids.
yeah, apparently I can't train with my own kids, but even though they'll be involved. I mean,
You can't train with your own kids, man.
so whatever. But
like
it's all day
working with
training,
dog
so I will
time,
not be
usually
here. This is the only day they allowed it to happen.
So the test is a week from this coming Monday.
So
So you're gonna have a kid.
I'm going to move it to a week from, so 2 weeks from today.
2 weeks from today.
Yeah, I've moved it to 2 weeks from today.
Okay.
And you, of course, can take it online, so you have until Friday
So it's the
at
second.
noon.
Yeah,
Yeah, the second.
You have it listed as
The first or the
February
second.
29th.
What's that?
In the video, you have it listed as February 29th.
Right, I forgot this was not a leap
Yeah,
year.
yeah. I was just like,
Last year was a leap year, so that's why it happened. It never happens. The test never happens.
That's what I was saying. One day it never occurred.
So you're gonna have a kid? Another kid?
Yeah.
Yeah?
Well, we'll try to.
Like me?
I don't know. How old are you, Tyler?
No, not like me. Like I have a kid.
Like you have a kid? Yeah.
Yeah, like my kid.
You can adopt me.
I can adopt you?
Tuition.
Adopt tuition?
You work here.
No, I
Will
think
you
you have to be
understand?
under. I think you have. Yeah, you have to be
No,
under
you can sell,
18.
you can sell.
I believe. Unfortunately. Yeah, it's
Dang.
weird.
I'm 16. And you believe it too.
As long as you have the birth certificate.
People still think I'm 12.
Yeah. A1 for looking young forever.
All right, so yeah, the final or midterms 2 weeks from today. That'll be right before break. And let's see. I think that's all we're going over today. All right, let's go over the quiz. Why would a developer use composition? Just realized taking it out of context is even funnier. But go ahead. What was composition?
That's making up on it.
Yeah, so it has a relationship. Why would you do that? Why don't you just put everything in one giant class?
So you
Why don't we just take one main function and write everything in main?
Because you break up the pieces, make it easier to work.
To use later on.
To use, make it easier to work on, use later on. Those are great. What else? How about in a large group?
A lot of people are working on it. You can find out where there's an error from one piece instead of trying to look through the whole
Oh, through the whole code? Yeah, so debugging can be a lot easier. That's true.
My notes say needed for differentiation.
Needed for differentiation, sure. So you're differentiating what parts to what, and why would you do that with a large group?
I didn't think that far ahead.
Fairness.
Fairness. Oh, that's interesting.
So you can say, that's my code. I'm like, no.
Oh yeah, so now you can so what you're getting at is you're assigning ownership of the code to a
Yes.
programmer. So that means one programmer is responsible for a piece of code, which is
So
actually
responsibility.
Sure, we'll get to that. Hang on. So which is actually very important. Code responsibility is very, very important. It's probably the main reason why Google worked so well is they adhered to strict responsibility. Every piece of code had at least one person who was responsible for it. So if there was a problem and you need to figure out who to go to, since they knew who did what code, they could get that knocked out as soon as possible. Other groups don't do that, and bad things happen. All right, so let's see. These are what the author said. Systems and subsystems can be used independently. It builds systems by combining less complex part. You can break it down, and it makes part of the code interchangeable, so you can do code reuse. All right. I think we've answered that question. Maybe I'll just put this question on the exam, because that was great. Oh yeah, here we go. Why do we use iterators instead of the standard for loop?
Less work.
Less work?
And faster.
Okay, maybe not less work, but it might be faster. Why would it be faster?
Oh, you said something.
Is it because there isn't like a conditional statement?
No, you're still doing, while has next, right?
I remember you saying something about it. Why?
Yes. What is it? Using an iterator, what does it break apart?
Did that?
It doesn't have an index, does it?
Now, it doesn't use an index, but using an index is specific to how an array works. So why using an what did the iterator do that broke it apart? Or split? What did it split up? The array. So the iterator just gave you an interface to adhere to, right? The iterator interface has next and next. Does the iterator tell you how it's accomplishing that? No. When you use the for loop, you're specifying how it is accomplished. So it's breaking apart the usage from the implementation, which means that whoever gives you the iterator can worry about the most efficient implementation, and you just have to make sure you adhere to the interface. So it breaks apart how you use it from how you use it to how it's implemented. So while let's see, ooh, that's a bad sentence. While iterators, the implementation, with iterators, the implementation is disconnected from the use. In other words, by adhering to the interface of has, next, we leave the iterator to implement the most efficient traversal strategy. In the last class, I showed the example where if you tried to do the for loop on a linked list, which we haven't talked about, it took forever. In fact, it didn't complete in class. But if you used an iterator, it happened almost instantly. And that's because the iterator was able to use a more efficient traversal algorithm than a standard for loop. So in other words, performance.
Take that as a win.
Take that as a win. So why do we have more than one class implement the list interface? So why do we have both linked list and array list? Touch base on this, but it's important to understand. Why would you want to have more than one type of list?
More stuff.
More stuff.
Different applications.
Different applications, okay, you're on the right track. That's all you got?
I tried.
So they both implement the list interface, but they do it differently. Why would that be important? What might be helpful, and maybe I should harp on this, is in computer science, with a lot of things, there is no one way that is best. The term is there's no silver bullet. So there's no one list that's better than all other lists. So there's going to be situations where a linked list is going to be better than an array list. Specifically, if you want to keep adding to the front of a list, welcome. The linked list will be far more efficient. But if you need to randomly access the list, the array list will be more efficient. Oh, yes. But specifically, to do that, what I was talking about, you'd have a list interface. That way, if you need to change from one type of list to another, you just have to change where that list is being instantiated, from a linked list to an array list, or whatever other type of list. All right, any questions on the quiz? Okay. There's no reading, because next class we're going to talk about solid, which is really just another way to explain everything we've learned in basically five points, hence the acronym SOLID. So we'll go through that pretty thoroughly next class. All right.